Welcome to today's previously taped webinar on battery storage, specifically BESS or Battery Energy Storage Systems. I'm Joe Lurch, Director of Local Government Policy for the Virginia Association of Counties, and I'm very pleased and excited to have an expert panels here to talk about battery storage, energy storage, get at a lot of different pieces of information that we think will be really important for counties and county officials to understand. So joining me today is Aaron Berryhill, Solar Program Manager with the Virginia Department of Energy, Chris Meyer, Senior Project Developer with Eastport Energy, and Anthony Natale, Director of Risk and Fire Response with the Fire and Risk Alliance, LLC. And actually, Anthony is on the road and going to be joining us as we're doing this webinar, but we think it should work out fine. So what I'm going to do is I'm going to kick this off, starting with Aaron, and then we'll go to Chris, and then we'll go to Anthony. And I may ask questions along the way if there's something that I don't understand that I think maybe our members would want to know a little bit more. And just so people watching this webinar know, a lot of things that we might reference, we're going to provide links and URLs to this on the website dedicated to this. So without further ado, Aaron, tell us about energy storage in Virginia, talk about energy storage targets, a little bit about different technologies.
Yeah, thanks, Joe, for having me. I'll try to give a kind of high-level overview of energy storage and battery storage specifically in Virginia. There are a lot of state policies involved, and of course, we're seeing that trickle down to the local level. I'll start very broadly and just kind of contextualize. Any energy storage is really consistent of any technology capable of absorbing energy and storing it, and then re-delivering that energy back into the grid. And so historically, like pumped hydro storage has been used in Virginia, but more recently, a lot of the conversation around energy storage is specifically battery energy storage systems, or BESS, or BESS for short, which are batteries that are electrochemical and are storing energy currently largely for short duration periods of time, so 4 hours or less. That's a lot of what we're seeing currently. The most common chemistry is lithium ion, and specifically lithium iron phosphate, or LFP, is typically what we're seeing being deployed. The other common lithium ion technologies, nickel, manganese, cobalt, or NMC, that is more likely used in electric vehicles. Some of the early stage battery storage projects in other parts of the country use the NMC technology. It is considered a little bit riskier for thermal runways than LFP, or lithium iron phosphate. So we're seeing the LFP sort of taking over as the predominant chemistry here in Virginia. So as far as kind of the policy background, there's a lot of reasons for why we're seeing energy storage being deployed in Virginia. Some of the first energy storage projects deployed in Virginia were built in the early 2020s, so 4 or 5 years ago. And a lot of those were pilots deployed by some of our utilities that were enabled through the Grid Transformation Act to start piloting how they could incorporate batteries into their, largely their kind of grid services. And so starting to learn about how they could incorporate them for grid balancing, ramp up, resiliency. And so Dominion had 3 projects that were approved back in 2021 that were not part of the VCA, but part of a pilot program that they deployed. I think there were 2 2-megawatt and 1 12-megawatt project in New Kent, Goochland, and Powhatan County. And so Dominion's been reporting on some of the lessons learned in those projects. And then we've also seen a few co-ops and several of our municipal utilities voluntarily install energy storage outside of any requirements of the VCEA. Again, some of that is around some of those grid services. One of the other kind of major reasons for energy storage is what's called price arbitrage. So especially some of the municipal utilities that are not generating any electricity and they're buying all their power. So Danville, Martinsville, I think Harrisonburg and Manassas are others that are looking into it, are looking at energy storage as a way to lower their costs for purchasing energy because they're able to build a battery and then buy more electricity when the cost is low and then just charge it and not pull from the PGM territory when the prices are higher. So we've seen several of our smaller utilities do that as a cost saving opportunity. So then kind of the background for the BCEA is what formalized more specific targets for the build out of energy storage here in Virginia. And so that was passed in 2020. And there's requirements specifically for Dominion and APCO to build energy storage. So for Dominion, it's 2,700 megawatts by 2035. And so there's interim goals that they have to petition the SEC for at least 250 megawatts by the end of this month, by the end of 2025, which they have done. And an additional 950 megawatts by 2030, and then the final 1,500 megawatts of that full 2,700 by 2035. Similarly, APCO has a 400 megawatt requirement. I think it's 25 megawatts by the end of this year, 125 additional by 2030, and then the next 250 for a total of 400 megawatts by 2035. That's currently as written. There has been some legislative proposals that floated last year that are likely to return this year that seek to expand those targets quite significantly and add more details about short and long duration storage. Those have not come into law yet. So right now, this is kind of the framework that we're seeing currently. And so as a result of that, we're seeing more projects being built to help meet those VCA goals. And so we've seen both Dominion and Appalachian Power petition the SEC for projects to meet those goals. And then there's also a requirement that a certain portion of those projects are third party owned. So we're also seeing those projects being proposed at DEQ for permitting as well. And I think we'll talk a little bit more about the permitting more specifically, but we have two kind of processes similar to solar for how projects are permitted. Some go through DEQ through the permit by rule if they're less than 150 megawatts, or if they are not owned by a investor-owned utility. And then alternatively, our larger projects over 150 megawatts or those owned by an investor-owned utility go through the SEC CPCN process. Currently, there are 14 projects totaling 388 megawatts that have been permitted by DEQ, energy storage projects, and have another 8 projects that have filed a notice of intent that they plan to file an application soon. And then on the SEC side, they have approved a total of 12 energy storage projects totaling 275 megawatts. So we can I think we'll have a chance to get a little bit more into what those permitting processes look like at the state level. Then at the local level, we're also seeing quite a bit of activity in response to a lot of this demand to build more projects. So we've kind of been broadly sort of tracking both projects being permitted as well as local ordinances being established. And so there's been a lot of activity at the local level on both of those fronts. To my knowledge, there's at least 20 localities in Virginia that have passed a battery energy storage ordinance. And a large portion of those have been established in the last 18 months. And so there's a lot of questions coming to developers into our office about how to draft these types of ordinances. And then also seeing a lot of projects being actually applying for permit. And so the process is somewhat similar to solar in that there's the standard 2232 review through the comprehensive plan. And then there's typically a conditional use or special exception permit. And then like solar, energy storage projects are eligible for a siting agreement. And so I've been personally able to track down examples of roughly 15 siting agreements that have been passed by local governments specifically for energy storage projects. The dynamics of those siting agreements do look a little bit different from a solar project, both in terms of some of the project specifics as well as some of the economics. They are a little bit different in terms of what a megawatt means for energy storage. So we've been starting to track some of that data on projects. I would say the question that comes up the most across probably all of these topics, state permitting, local permitting, is fire safety. That's the question that we get most often. And so we're going to get into that more, I think, a little bit later on, but I'll just note that that's the question that we get most often in terms of kind of developing policies and questions. So I think that was kind of my initial introduction, but Joe, I'll kind of toss it over to you if you got any questions for me.
No, I think, Aaron, thanks a lot. This was a great overview. I had a couple questions. You were talking about the earlier projects that were done by the utilities prior to the VCA, and that these being these kind of pilot projects. Were those using the nickel, manganese, cobalt technology, or were they already starting to use the lithium iron phosphate technology in those, or do you know?
So that's actually a good question. I'm not actually sure about the initial phase of the first 3 projects that were all approved for lithium. I'm not sure the exact technology, but I think I'll also just caveat, I think important to note here, they've subsequently had 3 other projects approved in 2023 as an extension of that pilot, and none of those are lithium ion projects. So they're starting to explore some other chemistries. I think there's an iron air, a zinc hybrid, and a nickel hydrogen chemistry. And so like different operating temperatures, different timelines, like the iron air is a long duration. So I think a lot of our conversation here today will probably focus more on lithium ion, but there's also some pilot projects being deployed by Dominion for some other battery chemistry. So in the future, this is a pretty expansive field, but I think right now what we're seeing is lithium that's being deployed.
Yeah, so follow-up question to some of this is you gave some really good overall numbers of the amount approved, by the PBR process. I think it was 388 megawatts. The SCC process, 275 megawatts. I know for the PBR process to get that approval from PBR, you would have already gotten local approval for the siting. I don't know if it's similar with the SCC, but generally, what are we seeing in service right now in the grid in terms of overall numbers, roughly?
Yeah, it's happening so quickly that it's a little bit hard to keep track. There's not a whole lot of projects that are built. There's several of these smaller 2-4 megawatt projects that have been deployed. The largest project that I'm aware of that's deployed is a 20 megawatt project in Chesterfield, but there are several projects under construction. So probably a year from now, that answer will look very different. So we're starting to see that deployment really ramp up, which has been I know an increasing question that I hear from a lot of local governments is they want to go tour a project and visit a site. And right now there's just not that many sites. And so hopefully soon that the opportunity to go visit a site will be a lot easier. I know like the site in Chesterfield has been kind of the common one that a lot of local governments have visited or cited. So that's quickly changing. I'm not sure the exact number, but it's ramping up pretty quick.
Yeah, maybe there's an opportunity to future date, maybe to do kind of a virtual tour of one of these sites so we can provide it online, particularly for localities that it's going to be far to travel. So thank you. One other question, I had in terms of, the approval process at the local level. Are you starting to see concerns raised about fire and safety and hazards, and how are those being addressed at the local level, just kind of generally? And is it mainly through the ordinances?
Yeah. So there are, of course, a lot of questions. To my knowledge, there's no documented examples of any issues in Virginia that have occurred. There are, of course, a few examples of projects in other states. A lot of those have been built either with outdated technology or with built-in kind of not up to the current code. And so a lot of the projects built in Virginia are not subject to kind of some of those same concerns that we've seen in other states, but that has also brought a lot of questions around fire safety, just some of those examples in other states. Largely where that's being addressed currently is through standards that are sort of best practice called NFPA 855 that a lot of our local governments are addressing and specifically citing in their ordinance. And those are national standards that are updated every 3 years with a lot of involvement from industry, includes actual burning of battery cells to understand, what the process is. I will also note there's a process for a lot of this to be incorporated into our statewide fire protection code and our statewide building codes. And so that process is actually ongoing. And so there is a little bit of a lag in that. So the 2024 code cycle is currently ongoing right now, I think. So that will be incorporating the 2024 version of the International Fire Code here into Virginia. The 2024 version of the International Fire Code includes the 2023 version of NFPA 855. It considers a lot of those elements. And so in time, we're also seeing those best practices and recommendations from NFPA 855 incorporated into our state building code and fire protection code. I think what we're seeing is that because the best practices around fire safety are developing so quickly, that a lot of localities are wanting to get ahead of that code development cycle process, which may take 3 or more years from the time the NFPA 855 is updated to where those best practices are actually incorporated into the code cycle here in Virginia. So that's where we're kind of seeing local governments being proactive to kind of get ahead of what will inevitably incorporate it into our statewide code. So we're seeing that. I've started to inventory that. I think well over half of the ordinances that have been adopted, local zoning ordinances, have cited NFPA 855 here in Virginia as something that they want to see developers abide by. And we can talk more in detail when we get into the fire safety about what some of those elements of the NFPA 855 are.
I muted myself. I think that both Chris and Anthony are going to go into more of those details, definitely. I want to kind of, before I switch over to Chris, touch on 2 other quick little points. In terms of where it's located, when first battery storage or BESS was being kind of introduced as a concept in Virginia, kind of the concept was, hey, let's pair it with solar. So when a solar is operating and it's not necessary for it to be drawn down to the grid, it could be put into batteries. But my understanding is really it's kind of up to the utilities and the developers on where might be an optimal space. Are we seeing a lot of BESS paired with solar, or is it really just kind of depend?
Uh,
Yeah,
hey,
go
Chris,
ahead.
go for it.
Yeah.
Sorry, Aaron, you go ahead, sir. Apologies.
Yeah, I mean, I think there's a wide variety. I think as I spoke to kind of the different uses for energy storage and how utilities are using, there's certainly a use case for pairing them with solar that potentially increases the value of the electricity being generated at a solar site. But it also varies a lot of standalone storage, probably more so than solar plus storage that we're seeing now. And some of that is purely a price arbitrage and the economics of buying and selling electricity, and some of it is more to do with grid services or resiliency. But ultimately, like proximity to electrical infrastructure is the leading factor for siting of projects. I guess one other thing that I didn't mention, I kind of talked about the policy side of what's informing this. There's also kind of the market factors of ultimately, well, not maybe necessarily tied specifically to an individual solar project. An increase in solar, wind, and other things is also leads to more energy storage, and it's actually a good thing. Without energy storage, as we're shifting towards more clean energy, without energy storage would result in a significant overbuild of solar and wind due to its variability. And so energy storage has a really important role that the market is responding to, because to really reach that being more reliant on solar and wind, due to its variability, you would have to significantly overbuild it to meet your need without energy storage. And so there's a really important role in the market for energy storage as well. And we're starting to see some of those shifts occurring across the country, whether or not there are specific targets or policies promoting energy storage. That's just being responsive to changes within the grid across the country.
Yeah, that kind of makes sense. So if you have a lot of particularly, wind, and like we're getting ready to build offshore here, and, I think Virginia is now over 5,000 megawatts of utility scale solar. There's going to be times when that energy could be stored when it's not necessarily needed for the grid. So that kind of makes sense. And I imagine too, part of what's going on, and Chris, maybe we'll switch over to you now and I'll do a leading question. We're also starting to see potential longer duration energy storage, which even provides more value. So with that, thank you, Aaron. And we may come back to you with some more questions along the way. So Chris, please introduce yourself and East Point Energy, and talk a little bit about the kind of the developer side here and the permitting process and the technologies.
Yeah, no, and Joe, appreciate this opportunity. I'm a senior project developer here at East Point Energy, and I've permitted projects from the southern part of the state all the way up into Northern Virginia and to the sides, you might say, all utility scale battery energy storage. So, and East Point Energy, who I work for, was one of the original. I think they developed the first energy storage project with our Rappahannock Electric Cooperative, and the one that Aaron mentioned in Chesterfield, Dry Bridge Energy Storage. We developed that one also. That's the largest operating project here, and we sold that to Dominion, and it's been going well. And we're very bullish on Virginia here. We're seeing a lot of need, as Joe, you mentioned. We're adding a lot of solar. There's almost 5,000 megawatts. We'll have that offshore wind. And as Aaron mentioned, the energy kind of storage follows all that in order to kind of make, I think, the electricity grid work better overall and more economical too, right? So the primary kind of economic reason we have these and how they make these projects make money is that arbitrage. So basically buying cheap electrons. And if we think about offshore wind, for example, works best at night. That's not necessarily when we all consume a lot of power, though, right? When we consume a lot of power and the prices are highest is at 5, 6, 7 p.m. on a hot August day, and we're all coming home and turning on our air conditionings. That's where we get that peak grid or peak demand on that grid. And that's where then we want to basically take those electrons we charge our batteries up with at the cheaper hours, and then we shift those, basically sell those at that higher price, but lower than what again the other people there. So we're having actually more competition at that higher demand period, and that is then creating a lot of value. Obviously, we make money, but again, lowering prices for everybody else too. Okay. And so that's kind of the fundamental part. Aaron also mentioned, I think, a couple other ways that, we offer value and we make money. And I think it's just important for everybody to understand when we're talking about how our projects work and again, kind of benefit not only your constituents, but society in general. There is that capacity. So being able to provide power at kind of a moment's notice, a utility will pay money for that because sometimes other generators go down, we have a loss of demand. And basically, we just are holding that power, and the utilities pay us to do that, and to discharge whenever they might need. And finally, there's what we call frequency regulation. So very small amounts of power, like instantly coming back and off, and that basically allows the utility grid to function properly and give everybody the power they need. As I think Aaron also mentioned earlier, where do we want to put these projects? Do energy storage, they have to go on a solar, on a solar project? Or, and Joe, you asked that question a little bit too. They do not. They could be on the utility grid everywhere. There is advantages if a solar developer, for example, already has a project. They might want to, as Aaron mentioned, sell more power at a different time of day when it might be more expensive. Or they might have a constraint on transmission. So they actually can't put all the power that they're generating onto the grid right there. And so they'll hold some of it back in those batteries and then deploy it later. But the most important thing for our project is, yes, we need to be by that electrical infrastructure. It usually needs to be a transmission line or an electrical substation. So we're looking for parcels near there. Okay. The size of these projects, though, we kind of have two size projects. We have what we call a distribution size project for the local electricity grid. And these are, for example, for some of those municipalities, like down in Danville or Martinsville. Those are basically what we call 20 megawatt size projects, or about 10,000 homes that might provide power to. Or sorry, about 1,000. Don't know, I got my math wrong. 10,000 homes might provide to. And then the duration for, again, the 3 to 4 hours. Okay. Your transmission size projects are, again, maybe basically above 20 megawatts, and those are getting up to 300, 400 megawatts in other states, California, Texas, for example. We're not quite there yet. We're still only looking at like 150, 200 megawatt 4-hour duration projects. Okay. I will say also importantly here, your size of your project is about the physical impact that the amount of area you're going to need to acquire, or the acreage, is going to be kind of a multiple of that megawatt times duration. And the megawatt is how much power, again, can you put onto the grid at one time? And the duration is for, again, how long can you maintain that amount of power? And that duration requires, the longer you want to be able to provide that power, the more batteries you need. And the more batteries you need, the more enclosures you need, and the more space you need, basically, then to, again, have those on your project. All right. So a 2-hour duration project is going to be at 20 megawatts is going to be smaller than a 4-hour duration project at 20 megawatts, if that makes sense. I will also say, just for transmission size projects, we're usually looking for about 20 to 30 acres. Okay. And again, it has to be along the transmission line then, or a substation. So I just want to make very clear, like, the potential fear of, are we going to be acquiring thousands of acres for energy storage projects in a municipality or a county is very rare. And you can't necessarily put these right next to each other either, because they basically cancel each other out on that arbitrage opportunity. So, if one goes in, you can't put one in even a half a mile or a mile next door. It just not going to work and make sense. Okay.
Yeah.
I will say, sorry, go ahead, Joe.
Yeah, I was going to say, a part of my understanding is, like, and the way it was explained to me in terms of, like, amount of land, typically when we think of utility scale solar, it's like in the 7 to maybe 10 acre range per megawatt of installed capacity. I've heard a number, and maybe you can verify this. Think of 1 megawatt of storage, maybe taking up a quarter of an acre. Is that roughly about that? If you were to kind of,
you want to look at it from like a megawatt hour, okay? Yeah. Not a megawatt, and no, we can put 80 megawatt hours, so 20 megawatts 4-hour duration on 2 acres.
Wow. Okay.
And again, that's adjacent to a substation.
Adjacent to a substation. All right.
Again, if you're a transmission size project, and I say, again, I'm talking 150 megawatts, 4-hour duration, you're going to have to actually build your own substation, though, and we have to give that to the utility company in order to connect to that transmission line. That's why you have a little bit more land in those cases. Okay.
Gotcha.
I will say, kind of, again, sometimes we're not a data center, to be very clear, and we're not connected to data centers directly. Okay, we connect to the overall electricity grid, but the value of that, if you're thinking about like tax proposition for real property taxes or other benefits and equipment, there's a similar type of proposition basically from energy storage also, from basically the amount of land used. Obviously, if you're putting this on agricultural land and that was subsidized, you're going to get a lot more. It's going to be 100x, probably more tax revenue from a per acre perspective too. Okay. But yeah, I mean, we're ideal spot though is for us to have an industrial or commercial piece of property, zone property. I mean, we like to be like near those uses, and you do not want to be siting these near a multifamily residential location, okay, or anything like that. Just probably because more of aesthetics purposes. I want to say again because of a fire safety issue or anything like that. But obviously, you try to keep things more towards industrial use. Let's keep it towards an industrial zone property. All right. We're going to jump now to kind of the permitting considerations, and Aaron hit a part of those, and Joe, you mentioned some of those. But first thing is that the state does require us, because it is a type of energy generation technically, to do what's called a 2232 comprehensive plan compliance check. Okay. Now the county can decide it doesn't want to do that if it is feeling comfortable with the project kind of after it's learned about it. It can actually take care of it as part of a different thing that's called a siting agreement. All right. But this is basically though to protect the siting agreement and the 223 comprehensive plan check to ensure if a county doesn't have an ordinance in place, we can't just like slam it in there by right on something, that they always have the opportunity to basically have some discretion over it. Okay. So important there to know. What gets confusing is that you can have all these different types of permits that we have to do, right? So in addition to that 2232 comprehensive plan check and offering you a siting agreement, okay, we also usually do then a discretionary permit, whether it be a special exception, a conditional use permit, or a special exception, whatever it might be in your jurisdiction. All right. So I think the majority of developers expect to have to go through some kind of discretionary permit process. I think we're usually happy to do that. What we want is kind of clear kind of expectations though. And the ability to work with staff and the supervisor, the decision makers, and the community to basically though design something that again, obviously still makes our project economical, but also again meets all your needs and takes care of all the concerns and questions you might have. A lot of those things we have to usually worry about, and kind of were mentioned earlier, is fire safety and rescue. And we use and like to reference this National Fire Protection Association's 855 code that is again specific to energy storage. It has a lot of other codes in it that are references like UL 9540A. That's the example that Aaron mentioned where you'd actually, the equipment we have to go in has to go through a burn test itself. So they take an example unit and burn it all, losing millions of dollars. But just to see how's the fire come out of it, how far can these things have to be put away from each other, ensure for them not to catch on fire. Basically stress test it to the extreme to understanding these worst case scenarios of what could happen. What we also see and usually also advocate for in either a siting agreement or a discretionary permit is an emergency response plan. Okay. And that emergency response plan should be your whole kind of guide to if there's an emergency, whether it's a fire or something else, how does your local first responders respond to it in a safe way that keeps them safe and any neighbors or anything else that they might be nearby. Okay. That emergency response plan, we can give you a template of it usually during a discretionary process, but the best practice we think is actually to do it during the site plan review process, because that is when I'll talk about timing here in a little bit, but we will have a better understanding of the exact type of equipment that we want to put in to the project and the design. Okay. But that should be you're not going to get your building permit or your construction permit until you have that emergency response plan, if that's part of a condition to get our site plan approved. And that should always be reviewed by the fire marshal's office or fire rescue team, and you can even hire subject matter experts like the people we might hear from later, Tony, to come review that with you. Usually let's say the norm also is for us, and this is part of NFPA 5 for emergency response plan is required, is to use a specialized agency that does these throughout the world or throughout the United States to help us design, create those. Okay. Finally, I want to mention there just on fire rescue is we usually require, and then the developer pays for a training on that emergency response plan for the first responders before the project becomes operational. So before it even turns on and could potentially have an incident and again, also connect to the grid, the first responders should get a training paid for by the developer. Okay. And then there should be also a training every year offered after that, paid for by the developer also. Okay. Or the owner. So those are some key things, again, we usually see in a lot of the discretionary permits. Also, we usually see a decommissioning plan request. Okay. Again, we'd like to see the final ones of those, usually at the site plan review process. Again, once we finalize our equipment and other design characteristics, and that's where we can, a third-party engineer can help create that and get that done. We always like to see some kind of net value, though, basically, because this equipment and these batteries do have a lot of value in 10 or 15 years that we would want to take advantage of. Finally, we're talking about screening and setbacks also usually. A lot of people don't want to see things. We understand that. We also don't want people seeing our projects and they're not playgrounds. We don't want people messing with them, visiting them, getting any temptation to try to jump the fence. Okay. And so we're usually trying to leverage existing tree coverage, and that's there already. Keep that, screen the project. We're happy to take on any ordinance language that has specific designs for screening. We also have setbacks. I think the norm is usually at least an enclosure has to be 100 feet away from a neighbor parcel line at a minimum. Okay, and that provides plenty of kind of space between our fence, the project fence, and the enclosure for the fire department to be able to access things, our trucks to be able to access things, while also having enough screening to keep the project safe. Okay. But those numbers can also move a lot. Again, NFPA 855, which you've heard, can provide guidance on that. I mentioned siting agreements before. We can use those not only for basically, there's three things I usually see in those is one, if we haven't had a special exception, all these setbacks and other conditions, okay, but also you want to talk about if we're going to have a revenue share agreement, for example, or we're going to use personal business property taxes or M&T taxes later on, and how we want to tax the project after it's operational. And finally, there's usually a schedule on some capital payments also, and this is to help offset the cost of the county, for example, hiring subject matter experts to review our proposals. Okay, if the fire department needs some new equipment potentially, they feel like to be able to again respond to something, then there's some payments again before that. We usually try and know the bulk of the payments though are usually trying to be timed with a site plan approval, at least beforehand, and or something right before operations in order to align incentives, and the developer doesn't want to put out obviously a lot of cash, let's say just at the time of getting our permit or signing the site agreement, if we don't know we're going to do the project. I will just say overall, if we get a permit, it's probably still only 50-50 chance that we're actually going to build the project. Okay. Because the next thing we have to do then is go study the project with the utility grid and do what's called the interconnection study process. And that will take for a transmission project 2 to 3 years. Okay. And I think that's important to note. And then if we get through that, you're going to another 2 years of construction. So that actually that's for a transmission project. It usually takes us from getting a piece of land under control to actually turning the project on 7 to 8 years right now, unfortunately, for a transmission project. Just to set everybody's kind of expectations too when you might see some of those benefits. Okay.
Quick question with that, Chris. So on some of the smaller projects, which might be more of the distribution level,
yeah, the distribution project.
Could that go directly through the incoming utility or REC, or does it still have to go to PJM for review?
So your distribution projects, right, will go through your investor utility, so Dominion or Appalachian Power, and that's less. And so, sorry, and I didn't mention this, but those project timelines are usually 2 to 3 years. Again, if the permitting goes quickly, you'll study the project probably in parallel then in that case, and again, they can get stuff built out a lot quicker to connect. So 2 to 4 years is probably your timeline right now on those distribution projects. Okay.
Go ahead.
No, I was just going to say the last couple of things here is, obviously during our permitting, we want to educate the public. We want to talk to neighbors. We want to hear how to make the project better. So it is very common. And if it's not best practice or ordinance requirements for the jurisdiction, we will do community meetings. I would say most developers also try to do a training and education with fire and rescue also during the permitting process. I will also say again, and Aaron mentioned this, if there's for whatever reason no discretionary permitting that happens at the jurisdiction level, we still have to go through a state permit by rule process. And that permit by rule process does require us to submit cultural resource analysis, so making sure we're not impacting a cemetery or a battlefield or something like that. That we have to do threatened and endangered species analysis, all your basically environmental and other cultural checks to ensure that the project's not going to have a extraordinary negative impact on the site where we're at or the neighborhoods. Okay, so I want to be very clear with that we have to file all these other normal state kind of rules, that are basically the State Department of Environmental Quality oversees. Okay, so it's not just we can build anything anywhere if your jurisdiction doesn't have an ordinance.
Thanks a lot, Chris. Yeah, so I don't know if you had anything else, but I had just maybe one overall question, and then maybe we'll switch it over to Anthony.
Yeah, so I want to go a little bit, and Joe edit away here, but just for timing considerations, and we talked about that, we always go the land deal first, then we usually get the permit, and then we do the interconnection, and then the project, once it's going, the batteries do degrade, just like your cell phone battery degrades, or your and so you'll augment the project, which means basically add a couple extra enclosures, which we have basically designed for at the start of the process anyways. And then at years 15, basically, it depends on how often you use the batteries, just how often you use your phone. The batteries will have degraded to a certain point where then it's time to go recycle them, and we bring in new batteries, and we call it repower the project. Okay. Finally, just want to talk about kind of what these benefits are for these projects, I think, to the jurisdictions and society in general. But to start with, what they do not do, okay, is they're not going to provide a lot of long-term jobs. Okay, these are remotely monitored. They're just like a substation. Once they're built, you don't have anybody in a building there turning on and on the batteries or anything like that. Okay, so if you're looking for job creation, these aren't going to do that for you. They're also not going to bring down everybody's electricity bill in your county by $10 and $20 a month. All right. You can do that by taking the property taxes from it, and then reducing people's real property tax. But these are basically just going to stabilize those electricity bills as we see keep on kind of growing that. And again, there is some money there for everybody, but it is not going to significantly drop everybody's bills. They will not also kind of keep the lights on if a power, tree falls on the power line between your house and the substation. These just help the overall grid maintain reliability and stability. Okay. They will have a lot of initial construction work for your local contractors, civil, moving dirt, your fencing folks, et cetera, your landscaping folks. This is all going to be great work for them. There will be ongoing landscaping that's needed. And you're going to get a lot of sales, lodging, and food taxes during that construction from the crews that are working on that. I've heard of folks say, for one of these projects, you're an extra $1 million in some cases, and for some more rural jurisdictions, that can be really important. You do have those siting agreements, like I mentioned. You need to think about capital payments before it's operational, and then we want to push those out from a developer perspective until we kind of are in construction at least. And also you have what you can do a revenue share, okay, which basically fixes your payments from us, and then that goes up every 5 years based on inflation. Okay, and it's about started at $1,400 a megawatt. And that's the way you'll have certainty over 20, 25 years of what we're going to be paying you. Or you can do the MNT or personal purpose of property or something like that. Again, the batteries do depreciate. They're set depreciation schedules. And so that gets a little bit trickier and it's going to move around. But you all I think jurisdictions need to understand the sophistication of their kind of tax team and finance team and make a best decision for themselves. Okay. So Joe, sorry, I wanted to kind of just cover those things, and those are other things we usually end up negotiating with folks, and we have a lot of questions we get from supervisors. So, shoot, buddy, let me know what other questions you got.
Yeah, no, in fact, you kind of partially answered the question I had, which was the depreciation and changing out the equipment, that time frame. So you give me roughly 15 years. Putting the crystal ball, gaze to this. 15 years down the road, I think there might be potential for maybe updated technologies. So you could come in with a different technology that may provide more value in terms of electrons in the grid.
Yeah. So what we're seeing is like the original battery energy storage projects, and Aaron alluded to this. We're to a certain extent recycled trucking containers. You might say that we're repurposed. Now they're technically designed for all these things, but that had 1 megawatt hour in a big 40-foot kind of trucking and container. Now, what we're putting into our projects or planning are 6 megawatt hours in a 20-foot container. Okay, so it's just like the power of your laptops or your cell phones. The technology is getting smaller and more powerful, and I would say also safer. And so, yes, we will look at kind of putting in the new technology. Obviously, we're businesses, we want to make money, but that should also add a lot more value and then grid reliability, et cetera, to folks.
Great, that's wonderful. So Anthony, welcome. Glad you could join us. Anthony, tell us a little bit about Fire and Risk Alliance, your role there, and then jump right into, I'm sure, all the fun questions you get from localities, like what happens if it catches fire? What happens if, some of the, if there are fire suppression or whatever, something runs off into the land, So run us through that. But first, introduce yourself and the work that you do.
Thank you so much, Joe. I appreciate that. So Fire and Risk Alliance is a traditional fire engineering firm, but we do some very, very niche work. We do fire modeling, plume, explosion modeling. So our clients are basically range from all the utilities in the United States to petrochemical clients, all over the world. Essentially, at the end of the day, my role is risk and response. My team goes out, and they evaluate sites, write response plans, and conduct training for the fire services. So the people that work on my side are either active or retired officers in the fire services. When it comes to battery energy storage, no matter where you are in the United States, everybody seems to have the same 4 questions: fire, explosion, plume, and soil. I think it's very reasonable if these projects are going to be sited in your community to ask those questions. Those are the questions I would ask. So basically, let's get into that. So when we look at fire, what's the real concern? The concern is offsite migration, right? Is an event at a battery energy storage facility going to migrate from that site out into the community? So I think look first is let's compare residential and battery energy storage. The risk that we look at basically is the construction materials and spatial separation. So if we were to look at residential homes, our construction material is essentially, it's a Class A fire. It's predominantly wood. When you have a fire in a residential home uncontrolled, it's going to grow larger, very, very significant fire load. And the way basically houses are spaced apart in a community, you have a good risk of propagation to the adjacent homes, right? When you look at a battery energy storage facility, you're looking at a metal cabinet. Okay, these things are roughly 25 by 9. They're spaced apart. So their design, we've shifted away. We make sure that we would never think about using any type of combustible materials that would allow propagation. And then the other risk is spatial separation, right? Communicating fire, and how do we manage that risk? Through spatial separation. So if we put the containers far enough apart, we wouldn't see that. So that's what we look at when we look at the risk of how do we manage fire within these sites. So at the end of the day, the most important thing that occurs when somebody designs one of these sites is to identify the risk, which is the potential for fire, ensuring that you're using a cabinet that is appropriately separated from the adjacent cabinets based on the UL 9548 testing. And that is how we manage risk at these sites. To date, there has never been an event that we've seen fire extend from cabinet to cabinet to cabinet and has left the site. So I think that's very, very important to note. One of the other things that comes up in these discussions is the Moss Landing event. A very, very unfortunate situation that occurred. But from what's being proposed here, it's apples and oranges. So if we were to look at the Moss Landing facility, this is an 800 by 100 building, roughly a 1940s vintage power plant that was filled with batteries. This was installed in 2020. This would never be permitted nowadays. So in 2020, it was installed before code was available to guide the safety and installation requirements that you have today. So I think it's very important to note that. So we're essentially comparing that facility, 800 by 100 feet, to a battery cabinet. And the cabinets that are being proposed nowadays roughly look like a shed that would go into your backyard. They're roughly 25 by 9. So I'm not sure how we reasonably compare the both sites. And the reason that they were designed like this is to mitigate risk. The idea is if I have one cabinet fail, that's fine. It's not going to extend to the adjacent cabinets. So now when we look at suppression, another big topic that comes up, why do we suppress fires? For life safety and preservation of property. When we arrive at a house that's fully involved in fire, we can't save that house anymore. The focus of the fire services is to shift and look at the adjacent homes and make sure that fire does not propagate. Well, we follow that same rationale with a BESS fire. So if there's a fire on a battery cabinet, there's nothing to save. Whatever's burning is already gone. So all we do within the fire services is stand back, evaluate the conditions, and if any triggers occur that require our intervention, then we might apply a little water for what we call asset protection. Very similar to a residential fire. We don't want the fire to extend to adjacent homes, or we wouldn't want the fire to extend to adjacent battery cabinets. Let's just say if we had an extremely windy day, there are certain risks with every application, but with a good design, you could mitigate those risks. The other big concern is explosion. A lot of questions about explosion, and I think people read a lot of things on the internet. So let's talk about that. And I think where it begins is from lessons learned. In 2019, there was a failure in Arizona that basically resulted in an injury to members of the fire services. Essentially, this was an installation that was placed before code was available to guide the safety features. So again, 2019, prior to code, and this was an old walk-in type of a cabinet. Essentially what had happened was the failure of the cells produced a flammable gas. So the difference between fires and explosions are four walls, a floor, and a ceiling. If you have a natural gas leak outdoors, you have a fire. If you have a natural gas leak indoors, you have an explosion. It's irrelevant the gas that we're talking about because cells will emit hydrogen, natural gas indoors, or a gasoline spill. If I have a flammable gas leak indoors, if it's confined, I run the risk of an explosion. So following that event, code changes came out and required explosion prevention systems to be installed. Essentially what happens is if there's a detection of flammable gas within the battery cabinet, a fan system comes on, ejects the flammable gas, and maintains the flammable gas below 25% of the explosive range to eliminate any potential for explosions to occur. So Since those have been put into place, we haven't had another event. So I think it's very, very important to note that. I only wish, as a firefighter, the natural gas side would pick up as well. If you think about, like, in the fire services, how we deal with that, in 2019, the fire services went and investigated this cabinet to see what was going on, and they were placed in harm's way. That would never need to occur again, because now we have detectors that can allow us to see things remotely, and we would never put the fire services in a bad way. Yet, I still go out to residential homes and have to inspect them looking for gas leaks. How insane is that? So I think that although the industry has come a long way, I think one event within the battery community changed the entire direction of how these things are built. So I think, keeping in mind the safety of firefighters is of paramount importance. The other thing I would tell you is big concern is clearly plume and evacuations, right? Something that we've seen with a lot of these events. Who wants to be disturbed in their homes? Who wants to run the risk of possibly breathing in something that could contravene the quality of their health? So, you can clearly appreciate people's concerns. So I think we need to begin with the reality is that all fires are bad. So the notion that a battery fire is worse than everything else, this is not the case. So when we start to look at, like, fires, right? If you look at somebody who has a fire pit in their backyard, you're burning wood, you're going to get hydrogen cyanide. We stand there, we take out our phones to watch a car fire. The plastics that are involved, the rubber tires, we're not worried about that. Every fire is bad. So what we have to look at is there a trigger that is going to make us react? And what is that trigger? Are evacuations appropriate? So when you hear about battery energy storage, you hear the terms toxic. Is this an appropriate term? I think it is. Why? Because there are two gases that are produced when batteries burn. One is carbon monoxide and one is carbon dioxide. These are actually on the list of CDC IDLH gases. IDLH, immediately dangerous to life and health. Why? They're both asphyxiants. Okay. How much of a risk is that to us? These are the prevalent gases that come from these events. So if I look at carbon monoxide, right? Let's look at a scenario where we can have somebody who starts their car in their garage. Inadvertently, they do not open the door. Fire department shows up. Now we have to manage the scene, right? We have a fatality. When we make entry to go into that garage, we're going to open the door, shut down the car, remove the victim. So carbon monoxide just caused a fatal effect on this poor individual. When I open that door, that gas just killed him. When I open that door, am I going to affect the next door neighbors and the people across the street? The answer is no. Why? Because it dissipates. Okay. So I think that's the most important thing to understand. When we look at fires, that we have to deal with in the fire services, where it's really changed for us is plastics. So whether it's a battery fire or a house fire, right? Like you think about our homes, your siding is plastic. Floors are no longer wood, they're engineered, right? They're plastic. The moldings in our house is plastic. Fences around our houses are not metal, they're PVC. So when we go to these fires, you're going to see hydrogen cyanide, hydrogen chloride. You can see HF. Whether it's residential, you can go to a BESS fire and see this. A lot of discussions come up about HF. It's true, you can see it at a very, very low quantity, but it's also found in house fires. Where does it come from? Burning Freon. So again, I will never downplay any hazard. All fires are bad. So now what's reasonable? What approach do we follow? Do we follow the approach of anytime there's a fire, we're going to evacuate everybody? We don't do that in our society, right? Because whether it's a house fire, car fires, we don't evacuate people. It should be science driven. So what does that mean? I think the EPA did a wonderful service where they evaluated what these conditions look like, what the risk looks like, and they actually provided some guidance. Their suggestion was, if there is an event, you should start with a 330-foot exclusion zone. Begin air monitoring. That will allow you to either shrink the zone or expand the zone. There has never been a fire that we're aware of that evacuations were based on science. They were based on emotion, and people were just being very conservative. So now we're a little more seasoned in what happens at these events. And I think we have to use these tools and say, okay, is it appropriate if I'm going to get somebody out of their home? Right now, I can tell you we do a lot of plume modeling within the company, and my folks that do the plume modeling have never seen anything extend beyond 100 feet of the burning battery cabinet when we conduct these large-scale fire tests. So I think it's important to note that. So right now, that strategy of a 330-foot exclusion zone would be written into any emergency response plan that we produce. And that zone would be expanded or contracted based on actual conditions. Science should inform on evacuations, not emotions. And then I think the next thing we really need to kind of talk about is soil, right? A lot of communities we deal with, people drink groundwater, people have crops. So I think it's very, very important to look at, do we have a risk here? So I don't think most people understand that when a battery cell fails, this is kind of what a cell looks like. Basically, what ends up happening is liquid does not leach out of it. It produces a gas, essentially hydrogen. So that's discharge. So you don't have anything leaking from the cell. It's going to leak into the soil. The next thing that would promote kind of soil impact would be suppression, right? We don't recommend engaging in suppression because there's no value added. You can't save what's already burning. So we don't expect any runoff there. But there are people that would say, well, what if this occurs during a rainstorm? And I think that's a very, very reasonable question to have. So what I do is I try to point to existing conditions. So essentially, New York State had a couple of events that were tracked and investigated by the New York State DEC. This is open source that can be investigated on New York State's website. And what they had determined was that there was no soil impact that required any remediation. So I think that that's important. I think it's a good start, but to me personally, I would need to see a couple more events occur before I can take that and say I feel completely comfortable. Out in California, they had the Gateway Fire. This was a large indoor facility, very, very similar to Moss Landing. They try to engage in suppression. There was a significant amount of water that was produced in the runoff. This was contained and controlled, and this was sampled by the EPA. The EPA allowed them to release that. They didn't require any type of remediation. So I think that tells a very good story. And then finally, Escondido. So this was a fire that also had occurred in California, and those reports are open source online, and you should look into it. So basically, what they found was there was nothing in terms of runoff that would require any remediation. They basically followed the practice of protecting the surrounding exposures. They used water. That water was contained and sampled. And basically, they furnished those reports online. So rather than to sit around and say, what if, I try to point to events that actually happened to say, well, why don't we look at the things that actually occurred? And these are very large scale events on places that were installed well before code existed. I think this gave us a very, very good data points as to what would occur on game day and really allow us to address a lot of the fears that we may have. Now, how do we manage this risk? Well, essentially good site design. So what does that look like? We want to make sure that we have good fire access roads consistent NFPA 1, Section 18. You want to make sure that apparatus can transverse within the site. I think that's very important. Spatial separation within the site of the cabinets to prevent propagation is also very important. Developing a site-specific emergency response plan with the local fire department. So I think working hand in hand and agreeing on what a game day response would look like, understanding hazards and appropriate response tactics for each potential failure scenario is very, very important. And once that's agreed upon between the local fire department, the developer, and folks like myself or my company, that's when we develop a plan, and that becomes the platform for any training that is going to be given to the fire services. When you give training to the fire services on these locations, these are what we consider low frequency, high hazard events, right? Just like substations, things that we in the fire services don't get to see often enough to become good at. So how do we manage that risk? Plans and training. The plans guide our behavior and the training reinforces it. So I think that's very, very important. Joe, that kind of wraps up what I have.
Well, thank you, Anthony. This was really good. It was funny as you were going through there, I had questions and then you kept answering them as you went on. But I think what we've seen from a combination of you and Chris talking is it's really about engaging the locality at the local level and the citizens, addressing all of those concerns, particularly the ones that I like the way that you said, it's the fire, the explosion, the plume, and the soil, and then setting what is appropriate buffers, in building and designing these sites. I think the fire access is really critical. I also think that, as part of the host site agreement, that training for those professional responders, whether they're salaried or not, because we do have a lot of volunteer fire departments, and those professionals can use that training, and that fire response plan is really important. I don't have any more questions. I think what I'm going to do is follow up with each one of you on some of the URLs that, you mentioned some site source here of things that people could look at. Chris, use what
If I can add one more piece.
Sure.
So one of the things I think is very, very important is good information. So what does that look like? I think when a lot of people take the time to look up battery energy storage fires, folks may become very enamored with people that have titles and a good educational background. But when you dig deeper into the story, you find out that these are people that saw a news clip and they're given a 2-hour dissertation on what they think happened. So my personal opinion is, if you want to make good decisions, look at people that have nothing to gain by their stories. So look at the EPA, look at the county emergency management, the health department, folks that were actually at the scene, that have good data, not other people's opinions. I think it's very, very important, because when I go out to a lot of these meetings, these public hearings and open houses, I hear a lot of the same stuff, and it's bad information that's being circulated on the internet. So again, try to focus on the fire services, EPA, different regulators, again, who have nothing to gain but have the education and experience to collect the data points that are necessary to accurately report out on these events. So thank you very much.